Alright, so we're going to go ahead and move on to the next chapter, which is all about sampling distributions and the central limit theorem. So first, let's talk about what a sampling distribution is. So in statistics, a sampling distribution is a distribution of sample statistics. For us, we're going to focus on sampling distributions of sample means. To get a visual, we're going to look at a list of raw data and what a sampling distribution from that list of raw data looks like. So I have a set of 26 data points from a class of AP statistics students from last year. This is population data because this is all of the students in that class. And I sorted it from shortest student to tallest student. So my shortest student was 60.7 inches, tallest student was 70.5. And I can calculate the mean of that distribution by putting this data in a calculator and then running one var stats. We know how to do that. I'm going to pause the video for just a second and go ahead and put that data in a list so we can run one var stats on it. Alright, so you can see on my calculator screen, I've got the list of all 26 data points here. I'm going to run one var stat on that list. And we can see our mean, if I scroll down here, is 66.23, so that's just going to round to 2 inches. Now what I want to do is I want to collect random samples of size 5 from this population. I want to calculate the means of those random samples, and then I want to compare the mean of those sample means to the mean of the population. A little weird, so bear with me. So I'm going to collect random samples. So you'll notice I numbered my data points 1 through 26. I'm going to choose 5 numbers at random and create samples of size 5. I'm going to do the first one with you, and then I'm going to pause the video and create the other samples so you don't have to watch me run random int on my calculator repeatedly. So our first sample, I'm going to go to math, I'm going to go prob, I want a random int, repetition's okay, we are selecting with replacement. My smallest number is 1, my biggest number in the list is 26. I want to select 5 numbers, and I'm going to hit enter. And so the numbers I'm going to choose are numbers 7, 19, 13, 13, and 6. So I'm going to pull those values from my table. So height 7 was 64.4. Height 19 is 67.4. 13 is 66.1. And 6 is 64.4. So that is a random sample of 5 heights from this population of 26 heights. I am going to repeat this 9 more times. I'm going to pause that video so you don't have to watch me do it, but all I am doing is running this command over again, getting a new list of 5 numbers and pulling them from the population. You can see I've completed all 10 samples. And what I want to do now is I want to calculate the sample mean for each of those samples. I don't want to enter those all in a list, so I'm going to be lazy. I'm just going to add the numbers and divide by 5. So 64.4 plus 67.4, 66.1, 66.1, 64.4. I think I entered that correctly. And then divide it by 5, and I get for that first sample a sample mean of 65.68. I'm going to go ahead and repeat that for my other samples. I'm going to pause the video. You should, on your separate calculator, double check and make sure I do this correctly. Alright, you can see I've gone through all 10 samples and calculated a sample mean for the 5 data points in each sample. And what I'd like to calculate now is the mean of the sample means. So I want to take, I'm going to zoom out here a little bit, these 10 sample means, I want to add them together and divide by 10. I want the mean of the sample means. Mean of the sample means. I'm going to go ahead and pop these in a list just to make sure I don't make a boo-boo. I'll pop them in list 2. So 65.68, 65.56, 64.48, 65.6. Oh my gosh, why am I plussing? Because I have lost my mind, that's why. 64.48, enter. 65.6, 67.4, 65.8, 65.7, 65.5, 66.5, 65.9. That should take me to 10. Good. So we're going to run one of our stats on list 2. And we get a mean, zoom back out here, of 65.812. What do we notice? They're pretty close, but not exact. So why is the mean of the population not the same as the mean of the sample means when those samples were pulled from the same population? And the answer is sample size. What happens when we make our samples larger? So what happens to these two values, the mean of the population and the mean of the sample means, as we increase our sample size? Here we use samples of size 5. What if I use samples of size 7, size 10? What happens? And we're going to address the answer to that in our next video. If you have any questions about what a sampling distribution is, feel free to send me an email or drop by office hours. Otherwise, I'll see you in our next video.